Okay, welcome to the NUPOC Video Study Guide number 19. Let's look at question 16 in the General Math section of Guide 1. It's just asking us to find the radius of a circle whose area, or the number of square feet in its area, is equal to the number of feet in its circumference. So we have some sort of area here, and that has units of feet squared, and we have some circumference and it has units of feet. And the problem is just saying A equals C, so what does R equal? And there's actually two solutions. One of them is trivial and one of them is non-trivial. And actually, if you're following along with the study guide and the solution actually does find both solutions, or as we'll see, both roots to the quadratic that we're going to come up with, right? So let's bring this over here. Let's write this in terms of r, so we know that the area is just going to be pi r squared, and we know that the circumference is just going to be 2 pi r. Okay, so immediately we can get rid of these constants, the pi on each side, divide each side of the equation by pi, and we're left with r squared equals 2r. Now it's tempting to just basically cancel an r from either side, then we're just left with r equals 2, which actually is the correct answer. But when you eliminate a variable from an equation instead of a constant, you may be eliminating some possible solutions. In fact, this is one of the things we touched on in the very first problem we did, so that would be back in video 2, where we actually solved an equation with two variables. So one equation with two variables, and we solved it and we found a solution to it, but one of the caveats was we had to treat a variable like a constant, and we may have missed some possible solutions. So if we treat r like a constant and we cancel one of them here and get rid of this one, then we'll miss one of the solutions. So let's go ahead and just treat it as we would any other quadratic. So we'll just move the 2r to the other side equals 0. So there's a couple ways to do this. Number one, we could do the quadratic formula, or we just factor out an r, and then we'll look at the two roots, and then we could set each root equal to 0 and then see what r could be. And that's the method they use in the solution. So let's do the quadratic formula version first. So we're just going to have, if we do the quadratic formula, we will have, let's see, 2, right, minus b plus or minus b squared is just 4, minus 4ac, which is 0, over 2, so this is just going to give us 2 plus or minus 2 over 2, so the positive solution is going to be 2 plus 2, or 4 over 2, which is going to be 2, and the negative solution will be 2 minus 2 over 2, or 0, right? So from this we get r equals 2 feet, or r equals 0 feet, right? Which is physically, you think about it, I mean, it's basically just, it's a circle with 0 area, 0 circumference, and 0 radius. So it's basically, I mean, it's a trivial solution in a physical sense, but it is a solution to the equation. All right, so that's from the quadratic equation. Now another route we could take is just factor out an r. So we factor out an r, we're left with an r minus 2. This is the path the solution takes, equals 0. So that means either r equals 0 or r minus 2 equals 0. So that gives us one possibility is r equals 0. The other is r minus 2 equals 0, or r equals 2. So we get the same solutions as we do over here. But of course, in all reality, the r equals 0 solution really isn't physically meaningful. So let's just go ahead and say that r equals 2 feet.